So we are in the middle of discussing this worldwide phenomena, the World Wide Web. But first, a few questions. So we saw that the web application employs the HTTP protocol. This is based on the client-server model, and we saw two types of HTTP connections, persistent and non-persistent connections. In this video, we will look at HTTP message format and a demo of the protocol. There are two types of messages employed by HTTP. One is a request message, and in response to this request, the response message is sent. So here is an example of a request message where I'm trying to download my web page. So the first line says get my web page. So this is the URL that I'm specifying, wherein I'm specifying the directory within that particular host. I haven't specified any file name because normally the servers know if you don't specify a file name, which default file name to pick. But if you want a specific file name, you can specify it after this. And then you specify the version of the protocol that you're using. So this first line is called a request line. And it has this particular format where there is a method, get is a method. There are other methods we will look at shortly, followed by space and then a URL followed by space and the version. And this refers to carriage return line feed. Basically, when you press an enter, this is what happens. And as you can see, all this is in ASCII as well. After the request line are header lines. What I have shown here is only a subset. So one such header line is the host where I'm specifying the machine. Do you think this is necessary to specify? Well, I have actually established a TCP connection to this particular host over which I'm sending this particular request message. So why do you need to specify the host name as part of the request message? This helps when we are using web proxies. We will cover this later. Another header line is specifying the user agent. In other words, what is your browser? In this case, I've specified it as Mozilla. This is useful in case the response can be custom fit for a given browser. For example, the server may choose a copy of a web page that displays best when using this particular web browser. And I've also specified that the connection type is close. That means after you respond to my request, you can close the TCP connection. You don't have to keep it open. Through this header line, I'm saying the language I would like is French. If you have a copy of the web page in French, please pass it. Otherwise, you send me the default web page. So typically in a request message, there is a request line followed by this bunch of header fields. And then there is a blank line followed by an entity body. So for the get method, there is no entity body, but some of the other methods may have an entity body. So here are a whole bunch of methods. The get method we already saw. It basically requests for a web object. If the method is head, you are requesting for the header fields only. In other words, even if the server has a body, it will not respond with it. This is useful for debugging, where you really don't want to download the body. So head is also used at times to get the time of last modification of the web page without actually downloading the particular web page. Put is like the reverse of get, where you are uploading an object to a specified path on a web server. Get doesn't have an entity body, whereas put will have the entity body filled up. Post is similar to put, except that the object contained in the body is appended. In put you kind of overwrite, whereas in post you append it. So post is used, for example, when you are posting a message to a news group. So this message is appended to the entire messages of the news group. So the method delete will remove the object specified. So the method trace asks the server to echo back the incoming request. Again, this is used for debugging. Connect is a very recently added method which is used to facilitate secure connections when using proxy servers. If you want to know the properties of a specific object, you can get to know about it using the options method. Patch is again another recent method which is similar to put, except that it permits partial modification of an object. Put basically replaces the object, whereas patch modifies the object. The most commonly used ones are the get, head, post. So once a request message gets to the server is going to respond with a message. Here is an example of a response message. So the first line here is called the response line. Here it will specify which version of the protocol, a status code, in this case it is 200, and a phrase corresponding to this particular status code. This is what is also shown here, and following the response line are again a bunch of header lines. So it will specify the date at the timestamp at which it is sending this particular response message, the server type, in this case it is Apache, this particular object that this particular server is sending, it will also specify when was it last modified. E-tag is used again in the context of web proxies. Sometimes you want to resume a download from a halfway point, in which case accept ranges specifies whether the server supports this kind of byte level downloads. Content length specifies the length of the particular object in bytes. Content type specifies the type of the object. And after this is again a blank line, which is represented by carriage return line field followed by the entity body. By the way, these are again only sample headers. There are a lot more header fields possible. And this is the overall format where there is a response line followed by header lines, followed by a blank line, followed by the entity body. Let's also look at a few status code and phrases. You may have seen some of these already as part of your web browsing experience. So when you get a status code 200 means the request was successful and whatever you asked for is enclosed. 301 is used to indicate that the object you have requested has moved permanently, and the new URL is often provided under the header field location. If you ask for something which is not been understood by the server, it will say 400 bad request. 404 not found is when the requested object is not on the server, and if the service is unavailable because the server is overloaded, it gives the 503 service unavailable phrase. And if this particular version that you asked HTTP it is not supported, it will give this particular status code. Again, these are only a sample set. There are a lot more status codes. As mentioned earlier, a web page once you download is going to contain a variety of objects: JPEG, MP3, MPEG, doc, PDF, so on. Now, how should one display this web object containing so many different formats? Now, should one include all these interpreters as part of the browsers? This turns out to be rather difficult because there are really too many file types out there in the internet. So the way this is handled is that the server indicates the type of the object via the MIME type. This is the content type I was showing earlier. And if this particular type is not built in as part of the browser is going to consult a table which specifies which viewer should be used to display this particular content. There are two methods that are followed here. One is the plugin mode, where actually the browser itself loads a code module which is going to run within the browser. And once the display is done, the plugin is removed from the browser's memory. So for an example of a plugin is a Flash player or a Java plugin. Sometimes a browser may also employ helper applications, which are basically a separate program that run as a separate process independent of the browser. For example, if you want to display PDF within your browser, you can pull up Acrobat Reader, or if you want to display .doc, you can pull up Microsoft Word. Another note on web pages. So the earlier web pages were static, consisted of HTML with images embedded within them. But these days, the web pages are rather dynamic. That is, the content is generated based on demand. What do I mean by this? For example, you as a user are doing some shopping, you click checkout, in which case, based on your click, the page to display to yourself should contain a list of items in a cart. Rather, what to display to the user is a function of the user's action in the past. It's not a standard display. So this kind of dynamic web content generation is handled via scripts which are embedded as part of the web pages itself. So this is called dynamic HTML. So on the server side, you can use PHP, which stands for Hypertext Preprocessor, or Java Server Pages, JSP. And at the client side, you can use JavaScript. So the HTML4 version uses these tags called script, through which you can embed script as part of your HTML page itself. Now that we understand the message format as well as the architecture of HTTP, let's look at a demo. So here is a demo of the HTTP protocol. All this is being feasible only because these protocols are ASCII based. So much like before, I'm going to telnet to the web server. In this case, it is the CSE web server. So by telnetting, I'm establishing a TCP connection between my host to the CSE web server, where I'm specifying the destination port as 80 because that's what the web server is listening on. And what I'm going to do is I'm going to act as the web browser, wherein I will type in the request message, which consists of the request line as well as the header lines. As a consequence of this, the server is going to respond to this by giving me the requested object. So let's see that in action. So I'm going to press enter, and then I'm going to download my web page, and I'm going to specify the protocol version, and I also need to specify the host name, and there it goes. As you can see in the response message, there is this version, the status code specifies the date, it specifies the server, it specifies when this page was last modified, and a whole lot of other things. And after this is the entity body, which actually is a HTML page. And after it sent this particular web page, it has closed the connection because that's the default behavior. Pretty neat, huh? So to summarize, web had a tremendous impact on our lives. So the web application follows a client-server model. We have seen persistent and non-persistent connections. We also looked at the HTTP message format in the form of request and response. Up ahead, we will see a few other miscellaneous yet very important aspects of web.